Welcome to this short video on hierarchies within stars and cubes. We're going to explain why hierarchies are useful, and also why snowflakes are now less important than they used to be. Remember that one of the aims of the extract, transform, load process is to transform complex data sources into simple stars. What we are showing on the screen now is the data schema for the AdventureWorks operational system, with many tables and all their various interrelationships. You can see various tables such as the sales order details and the products, subcategories and product categories, but they are rather lost in all of this detail. It would be much simpler if we could give the analyst a schema such as this, with the sales pulled together into a central facts table, and then dimensions describing the different things that the analysts may want to investigate the data by. One of the big advantages for us for producing simple stars is that once you have a simple star, then it's often a one-to-one correspondence to making a cube, so designing the star itself generates the cube. However, in going from the complex source to the simple stars, we ought to make it clear that usually the business would design several different stars, one each for the different area of analysis that it's going to look at. It really doesn't matter if parts of the same source dataset get duplicated into different stars. These are only copies of the data. Within each star, the facts table is likely to be tens of millions of lines long, whereas each of the different dimensions is likely to be quite short. For example, the product table will only be 500 lines long if you sell 500 products. Or the customer table might only be 1,000 lines long if you have 1,000 customers. Even the dates table will be something like 3,650 different rows if you have 10 years worth of days in there. Given that the dimension tables between them probably occupy less than 0.1% of the whole database, it really isn't economic to bother putting too much effort into reducing their storage space. Not normalizing data is perfectly acceptable. Here is an example from the AdventureWorks Data Warehouse dataset of the sales territory dimension, and you can see that there are 10 different areas that the company sell to, and they are listed out. But look at the country and the group. 5 times over it's stated the United States is in North America. It's redundant and unnecessary to write this out quite so many times, but in fact, if we were to do anything about it, we would only save writing out 5 lines of data, and in mega or gigabytes of database, saving 5 lines is neither here nor there. So, in this video, we're going to create a cube from a non-normalized dimension table. That is, a flat table containing all the information that we need. This will be very easy. We will then create another cube from the equivalent but snowflaked source. You'll see there's 1 or 2 more steps, but essentially it's going to be the same task. Let's start with creating a cube from a non-normalized dimension table. So let's do this by creating a new star. We'll first connect to a data source, and we'll select the AdventureWorks Data Warehouse. And from this, we will select the Internet Fact Sales, and ask to see where these have been sold to, so the sales territory. And so we have the fact table pointing to a single dimension. Then, using this source, we can build a cube. So a new cube, using the existing tables, and the source is going to be the one that I've just created here, with its internet sales and sales territory. It asks us which the measures are coming from. That's going to come from the facts table. In this particular example, there are many possible measures. I'm going to keep it very simple and just search for the order quantity and the total sales amount. And then it's asking what dimensions we want. Clearly we want the sales territory, but we don't need the fact sales. There's information there we don't need for this example. And finish. And then we could generate the cube. Good. Select the cube and browse it, and this generates the table that we wanted. However, you can see here that although we can look for the total order quantity or the total sales amount, at the moment the only way we can see where things were sold is by looking at the territory key, and this names things by number alone, and that's not what we wanted. So if we close this and go back into the cube designer, we can see here this is what's available on the source, this is what's in the menu at the moment, and at the moment there is nothing. So we can take the country region, the country itself, and the grouping of the countries. These will now appear on the Excel menu, but if we want to drill down the system, we would like to say inside different groupings of countries, we then get the country itself, and within the country itself, we then get the region. And let's rename that Sales Territory Hierarchy, and reprocess the cube. And this time, as well as being able to see the order quantity, the total order quantity ever, or the total sales amount, first we could look by different fields. We could select to look just by the territorial group or the territorial region, but more importantly the hierarchy, and place it within row labels. Then we can start drilling down. It will always show us the top level, which is the different groupings, and within any one of those we can then drill into the different countries, Canada and the United States, and then within that we can drill down into the different regions within the United States. So the key point we've made so far is if you add to the menu the various items that could be in the cube, we can then arrange them into a hierarchical structure that allows us to do these different drillings. And to do that, first will be dragged from the source onto the cube structure, which affects what we can see within Excel, and then from the cube contents into the hierarchy. But we were fortunate in this example because the data source we were drawing from already had the table with the country, the region, and the group already laid out. All we had to do is put it into the right places. But what happens if the data is already snowflaked within the source? Let's explore that. The example we're going to use to show snowflaked dimensions is the product dimension. In the operational system for AdventureWorks, it already contains 3 different tables to do with products. There is a table describing the different properties of products, and this has a reference or a link to a subcategory table. This second table lists out the different sorts of subcategories, and it also has a link to a category table. And there are names for each of these, so each product is named, each product subcategory is named, and each product category is named. We could try combining these 3 tables together, so in our star we would end up with a single table that would be the dimension for the product, combining these different values together. To do this, we would need to write some SQL, which would effectively join these 3 tables together using the different identifiers. But in fact, we don't have to take that approach, and demonstrate instead of taking our source from the data warehousing source, this time we will create a new data source and link to the AdventureWorks transactional system. And in this particular example, we will see there are many tables. If I make it wider, you'll be able to see these more clearly. And we will look at the different sales. That came from the sales area of the database. Now we'll look in the production area and bring out the product subcategory, and the product category. And then need to rearrange these just a little bit to help illustrate. You can see the snowflake there for the products, and we will need to join these to say that the sales included a product being sold. So we have a very simple star in this case, with a facts table leading off to a single dimension, but in this instance the dimension is snowflaked. Let's now create a new cube from this. And I've been careful to select the data source that I've just created. First, it's going to ask for the measures group. That is, all the sales, they're listed in the sales order detailed, the line-by-line sales. Again, I'm going to simplify this into the number of orders and the total value sold. Here is the dimension, and you can see that following the structure of the product, subcategory and category, you can see the product, subcategory and category snowflaked. There are also some items in here that we don't need to analyse, so we'll hide those. But, just like before, we're going to have to define what goes into the different dimension areas. So, let's go and design this. And this time we see the data source view is made out of 3 different tables. And we're going to select, to include in the cube, the name. But since we've got several names, rename this to the product name. We could also ask to look at the colour and any other particular attributes that we wanted to choose. I'll choose size. Then bring in the product subcategory name. Because it's ambiguous as to which name, let's rename that to the product subcategory. And finally, let's ask for the product category name. And for the third time, rename that. If I had a little more time, I would normally hide the different IDs. We wouldn't normally show those to the users, but I won't do that on this occasion. And then, to build a hierarchy, we can do very much as we did before. Set up a hierarchy with the top level is the category name, within that is the subcategory name, and within that is the product name. And rename all of this into the products hierarchy. Build the whole cube. And you can see here, we have the 2 measures that we selected, but we also have the products hierarchy, which we can load, and this is going to allow us to drill from the top level into the second level and even into the third level. This has ended up with the same result as working from the non-snowflake schema or the flat tables, but working from the snowflaked we had to do slightly more drags across, a few more name changes, but we didn't have to write the SQL. So it's a balance. Which would you prefer? However, we started by saying that why snowflakes are now less important than they used to be. And the answer is because within the cube structure we can define the hierarchy irrespective of whether it comes from a flat table or from a snowflake. Thank you for watching this video.